Perth Linux Users Group, talking Linux and open source.
Great. I'll stand over here so I can see the screen. Is that good for you? Right. Apologies for the aspect ratio. Right. I'll get straight into it. My talk will cover what C++ actually is, because these days there's probably people who haven't heard of C++, and those that have probably think, oh, that's like C with objects, isn't it? I'll talk about the paradigms of what you can do in the language. I'll talk about what a Hello World program looks like, why you should use C++, why you should not use C++, and that's not contradictory because it's obviously a right tool for the job type situation, some C++ and Linux, and if we have time, I'll do a demo. So I probably won't be able to fit in a demo. Apologies for that. C++ is a statically typed language. This means that any object that you have, the compiler will have to have been told or will have determined a type for it at compile time. It's not like PHP where it dynamically looks in the contents of a variable and figures out how to interpret it based on the contents. Nor is it like something else like Java where you can have a reference to an object and that can in fact contain any object. C++ has different reference semantics to Java. I'll get to that later. C++ is multi-paradigm. That's not multi-platform, it's multi-paradigm, although it is multi-platform. I'll talk about paradigms in the next slide. It's compiled. This is good because a compiled language gives you really good speed benefits and lets you do profiling to make sure that the real hotspots in your code are executed efficiently, and if need be, you can change and tweak compiler optimizations such that you get your code running as fast as possible. Although unlike 25 years ago, these days scripting languages do automatically compile themselves to bytecode, which does run quite fast. So the whole compiled versus non-compiled thing is a bit more of a grey area than it used to be. C++ is general purpose. It's theoretically possible to write any program in C++. Paradigms. C++ is designed to let you do multiple things at once in the same program. Procedural programming is simply the start executing the main function, run a number of other functions. When they all finish, or when one of them exits, the program drops back out to the command line, or if it's a daemon, it will just stop running, or it will restart itself, or something. So really, in that sense, it's no different to C, or many of the procedural languages we're all used to today, like Python, or Perl, or even C#. Okay, the other paradigm you can use C++ in is action. C++, unlike C, is really good for composing objects out of other objects. It is possible in C to have structs, but C++ takes it to the next level because these data types are object-oriented, unlike the ones in C, where you have to do all the object orientation manually. Oh, look, I just talked about object-oriented programming. But for those who don't know, object orientation generally is composed of inheritance, polymorphism, and object focus rather than code focus or data focus. I won't be giving a presentation about object-oriented programming today, but if you want one of those in future, let me know, I'll come back. Lastly, and most importantly, the paradigm that C++ is also good at is generic programming. This is where you write an algorithm, but you don't specify the type of data it works on. You're allowed to have certain assumptions, like when somebody uses this algorithm, the data type that it works on must be able to walk, crawl, and hide in a box. So this is not some kind of wacky functional programming thing where you're writing a macro that will work on absolutely anything. But what it does let you do is separate the algorithm you're writing from the type of data upon which it's intended to run, and I'll talk about that a bit later. This is an example of a Hello World program. Firstly, you'll notice it looks quite a bit like a C program in the fact that it uses hash includes and it has a main function with a return type. It uses open and close braces for a block, in this case a function body. It also returns a value. Therein lies the end of the similarities with C++ for this program. I'll point out the differences now. You'll notice I'm including a header called iostream that does not have a .h on the end. That's a deliberate distinction in C++ because all of the system headers, and in fact most of the headers that you will include from other libraries, that's a lie, some of them do but most of them don't, miss off the extension on the end. And there's a reason for that, why would an include file have to be a file. In C++, the standard merely specifies that an include file has to be some kind of includable resource. So why denote that the resource has to have a .h on the end? They could all come from the same file, it doesn't matter. But anyway, we're including IOStream. That means we have the basic stream concepts that are used by the program to do input and output. As in C, it has a main function, and where you would normally have a printf in a C hello world function, you now do something with objects. But first I'm going to talk briefly about namespaces. In C, you have two types of linkage. You have static extern linkage. Extern linkage means a function or a bit of data is available to anything that you link into your program. So all of your function data are all mashed into one big namespace. This is very difficult to work with on very big projects. The other sort of one, static, is where the names are only visible within inside the .c file in which they're present, and they're not visible to anything else that you link that file with. So in C++, Bjarne Stroustrup, which is the correct pronunciation of the guy who invented the language, it's not Bjarne Stroustrup, as you might think, it's Bjarne Stroustrup. He decided that namespaces would be a good way for different libraries to containerize what they provide. So as you can see here, we're using std, which is short for standard, and in that namespace there is an object called cout. It's an object that has a class that is one of the IOStream classes, and it represents the standard output of the program. The next thing we're doing is we're using an overloaded operator. C++ allows you to overload any operators that are already existing in the language from C. In this case, the left shift operator has been overloaded to mean send some data into an output object. This is called insertion. We're inserting a struct which represents standard output, and that makes it be printed on the screen. So we've already introduced a number of the fundamental, different and yet important concepts for C++, even in a Hello World program. However, it is possible to hash include stdio.h and use printf just as though this were a C program, because in most cases C++ is a superset of C. Are there any questions before I move on to the next? The \n will work because \n is a character that's present in an array, and that will actually get output by the terminal driver and it will be flushed when the program quits. Good question. He was asking why did I not use std : endl, which is the normal object that you would use to signify the end of a line, and the answer is you don't have to unless you specifically need to flush the buffer. Other questions? No, moving on. Right, there's a few to use C++. Operator overloading. It's very important because you no longer have to use method calls for everything. In addition, you can have what's known as global operators, where instead of a operator being a member function of an object, you can have an operator that exists in the global namespace and has a left-hand side and a right-hand side, and will automatically convert either object, either side of it, if possible, to an appropriate type to be able to let it be used. So that sounds like a lot of explanation, but what it means is you are allowed a lot more flexibility in operating. Operator overloading is also very useful because it lets you create custom data structures that do things in interesting ways. You might want to make your own string type where when you do plus equals with your string object on the left-hand side, it will automatically do some magic with the data on the right-hand side of the plus equals. So operator overloading can be taken too far, but it is also very handy. And in an interesting way that means it uses streams. So the extraction operator, which lets you read data from a object or standard input into another object. And in the extraction operator is the right shift, which is double angle bracket. So it's the reverse of the insertion operator. I won't go into much more detail about I/O, but there's a lot you can do with it, and it all works the same. It's very flexible, and it means you don't have to use snprintf with format strings. That C++ has that C++ very, very useful, because no longer do you have to take the address of something just to pass it to another function without passing the whole object. All right? A reference is like an implicit pointer, but you can't change the pointer. you cannot set it to null. You can only access the original object through it. It's a bit like a safe alias rather than a pointer. References are very cool, and in practice, very much like the references in modern object-oriented languages like PHP 5, Java, and Python. So C++ references are awesome. You have the concept of const, which somebody would probably tell me, yes, but you had constant pointers in C, and yes, you did. However, C++ takes it one step further by allowing you to have things like const methods, which are methods that, unlike any method that is not marked const, will be able to operate on a constant object. Const is like a contract that the method will not modify the contents of the object. I haven't seen this being available in other languages, so this is really good if you need to prevent unauthorized usage of things by people using your library. And there's a stack of other things that C++ lets you do that let you control access to objects in a fine-grained manner. I won't talk about those in detail. But the golden rule of const is, whenever passing things to functions, if you know the function won't modify it or pass an object to something that needs to modify that object, make the parameter const, because then the function will be able to accept parameters which are of type const. And then those functions will be able to be used on constant objects. It's kind of a philosophy. Right, I've already talked enough about namespaces. Function overloading is very handy, and this is not available in C. Function overloading lets you write the same function three different times with the same name, and the only things that are different is the type and or number of arguments that that function takes. It's great because you don't have to say print underscore string, print underscore integer, print underscore thread. You just have three different print methods with the same name, and the compiler tells which one you want to call based on the type of the parameters you're passing to it. It's really awesome. And of course, speed. I would venture that nothing runs faster than C++ other than assembler, if you write your program correctly and don't use the wrong algorithms, because they can take up too much time, even in a compiled language. Questions, or should I move on? Right. C++ also gives you a lot of choice. So this is more of the why C++ thing. You've got a choice of libraries. There is the POSIX functions that you have in C and some other languages that are available in all platforms that have a C library or equivalent, like glibc. These are standard functions that are specified by the POSIX one of the various POSIX standards, and lets you do things like open files and do printf and all of that. They're all really simple. You also have Boost, which is the way that C++ gets features that are not part of the standard. Most things that end up getting incorporated into new C++ standards were part of the Boost set of libraries before they made it into the standard. There are also many, many other libraries which I try and keep track of as much as possible, which let you do other cool things with C++. There is also a choice of GUI libraries. There is Qt, which is the GUI library that KDE is written in. There is WX Widgets, which is available for many languages, not just C++, and that's cross-platform, like Qt. There is also GTK-MM, which lets you use GTK Plus with actual C++ objects, because I'm not sure if there's anybody here who's used GTK Plus under C or under Perl, but you have to do all of the object orientation yourself by having pointers to fun-side structures, and it can get a bit ugly. It's the way that Linux kernel does it, but for GUI programming, I would argue that there should be a better way, and that's why somebody came up with GTK-MM. So yeah, there's many, many, many libraries available for C. You can link to libraries that were written for C in C++, but you have to be a bit careful about it. You can't always expect to just use a C header and a C library and get it to work, because the way that C++ links with libraries uses different calling conventions and name mangling than C does. So just be aware of that. That's a trick if you're not expecting it. It's quite easy to wrap that sort of thing though. Right, C++ has templates. I spoke a bit in the intro about generic programming. Templates are the way that C++ does generic programming. I would need a whole 1 hour talk to discuss templates in detail, so I'm not even going to gloss over them now. Suffice to say they are the mechanism by which C++ does generic programming. They're incredibly powerful, and just for lulz, it turns out that the C++ template mechanism is Turing complete. which means you can write programs in C++ that run at compile time and produce a constant output. Someone even once wrote a book on all of the magic things you can do with templates to achieve that. C comes with a very large standard template library. Most of the algorithms that are used for working with data under C++ are in the standard template library, which means they will work with any type of object you want to use. You don't have to, like Java does, have objects that are all descended from one parent class. Although in fairness to Java, they have introduced something quite a lot like C++'s template mechanisms a few years ago, so now it's not as ugly as it used to be. And trust me, Java generic programming used to be very ugly before they supported that. Boost has a lot of template-related stuff. It has things that go way beyond what's available in standard template library. Many of them are a bit ugly to use, but they're very, very powerful. I'm not disparaging Boost here, but just be aware that some things that are done in Boost that might seem like magic are done with heavy use of templates. Or you can roll your own templates. I've actually noticed some gaps in some of the things that the C++ standard template library does and written my own templates to provide those facilities. You can have template classes or template objects, even both. And it means you, as I said earlier, can have your algorithms and such wrapped up in a way that does not predetermine what sort of data that they're used on. Why not C++? It's Baroque. There are people who've seen C++ and basically cringed at how much stuff is in it, how easy it is to write bad programs, although of course you need to be able to write bad programs in order to write really clever programs, and sometimes unfortunately there's overlap. I will admit that the compiler errors you get out of C++, especially when you're misusing templates, can be crazy, but if you take the effort to learn what it's telling you and get used to it, it is actually telling you what you need to do to fix the problem. C++ is compiled. This means you have to go through a compilation cycle and you have to have dependencies if you don't want to build a monolithic binary. It's a trade-off. Scripting languages compile their stuff dynamically to like .pyc files, for instance, but C++ you have to compile it with a compiler to an executable. C++ has also been criticized for its memory use because a C++ binary generally will take up quite a bit of space. And in a large enterprise class software project in C++, be careful because every time you use a template, it may use a separate chunk of memory for that particular use of that template. Right, now the thing I'll finish with, because unfortunately we don't have time for the demo, but if anybody wants to stick around or go to the pub afterwards, I can show you then. So this is virtually the conclusion. It is easy and quick to compile things. It takes one command line that you can do from memory. It's actually fairly easy to cook up make files that will compile your C++ project whenever you change something. You can even get make files that automatically determine which header files are depended on by which .c++ files. Very good, that. G++ is the package you use to compile stuff under C++. You can actually call it as C++. Because at least in Debian, the alternatives mechanism will specify which is your compiler for you, which is your preferred C++ compiler. There are packages for most libraries, like all of those Boost libraries I told you about. You can install packages under Debian that will mean that you don't have to manually install any libraries to be able to use them in your projects. When you link against a library in C++, you can take that binary and run it on a different system, and as long as those same libraries have been installed somewhere, your program will run, even if they're not in the same directory that they were when on the system you compiled it. If you do need to manually say that a library should be statically linked into your binary, you can do it, and it works. Won't go into the details of why, but sometimes you will need that. Okay, now, in conclusion, there's a very excellent book called Thinking in C++ by Bruce Eckel. It's available for a zero-charge download, and it's available on the web and also in ebook format. That tiny URL that you see there, if you type that into your phone or what have you, that will go to the big long URL that is present there under the name of the book. If you want to look up any of the classes that are in the C++ standard template library, go to cplus.com. It's been a very consistent resource that doesn't try and advertise at you lots for all of the stuff in C++. It's quicker and easier than looking up the documentation in a book. If you've got any questions on C++, I'd be more than happy to answer them. Use my plug.org.au address because that way I can forward things to the mailers more easily, and basically that's where my presentation-related emails should go. So, do any of you now here have any questions? Nope. All right. Thanks very much for listening.